So good morning and welcome to my presentation. My name is Giorgio Mannina and I'm professor in sanitary and environmental engineering at Palermo University here in Sicily. I'm in charge of leading the research activities related to the project of which regard, among others, 2 demonstration case studies here in Sicily. Here there is the outline of my presentation. I will briefly introduce the team which we are going to work on the activity, and we'll discuss the case studies with the objective, Marineo and Corleone, and I will conclude with potential challenge. Regarding the team, we are composed by 2 main teams. One is constituted by Palermo University and the other one is AMAP, which is one of the largest water utility in the south of Italy, especially in the west of Sicily. Then we have stakeholders that are already involved in the project, among others the Sicilian Regional Assembly, which is a sort of a regional government that has the power to promote law, as I will discuss later why we involved already this stakeholder. Then we have the 2 municipalities of Corleone and Marineo, and then Mugavero Teresa, that is one of the largest industry that basically produce fertilizer in agriculture and also export even into Asia. And then we have other stakeholders that we want to engage into the project in order to obtain a wider uptake of water smart solutions, such as agri-food producer, farms and their association, biochar technology, bioplastic industries, and so on. Overall, we have Palermo University is composed by 16 departments, and we engage inside the project 4 of them, in particular the engineering department, that is the one that I belong to, and then agriculture, food and forest science, biological, chemical, pharmaceutical and science technologies, and law departments. Why? Because we want to achieve a multidisciplinary team in order to tackle the topics of the project. Here there is a picture showing you that my colleagues that are involved in this project, that are basically permanent staff already as member of Palermo University, but we are going to involve also some other people such as PhD and postdoc and so on. This is the team that compose AMAP, that, as I said, is the water utility that basically manage the 2 wastewater treatment plant, Marineo and Corleone. Regarding the objective of the demonstration, so basically the main goal of the demonstration is to provide evidence about the feasibility for providing regular, sustainable and safe irrigation, and also slow down fertilizer for agriculture sector based on wastewater sludge reuse. So what we are going to recover from wastewater treatment is basically the polyhydroxyanides, PHA, and also recover nitrogen and phosphorus by using biochar and zeolite as a filters, and then of course water reuse and also sludge reuse. We are also going to optimize the 2 wastewater treatment plants in sense that we want to reduce the emission, both direct and indirect emissions, so the emission coming from the biological process, but also the consumption of electricity and so on. And we aim also to reduce the production of sludge that, as well known, is one of the crucial points at, I would say, world level. And for achieve these 2 goals, so the widespread of both sludge disposal of and so reuse of sludge and also water reuse, we are going to propose some regulation at the local level. So we already started with the law department to work on it. Which strategy are we going to carry out? So basically we are going to combine 2 main blocks. One is the experimental analysis by combining batch scale, pulse scale, and also the 2 demonstration
case studies, so making some experiments and trying to figure out how some process works in order to be optimized. And then we are going to use also the modeling, mathematical modeling activity in order to have to foster this optimization. And we are also to combine risk analysis, which include also health risks and relate to water use and so on. Regarding experimental activity, very briefly, so we have basically these 4 streams. First one is pHa recover, then nutrients recover, water use, and sludge reduction. And for all of them, we are going to capture first monitoring and then trying to minimize the emissions that affect, as well known, the climate change. So we are going to reduce nitrous oxide, and then of course CO2 and methane, which are the 3 main greenhouse gas. We are going to carry out bench scales, such as in the picture that are reported, that basically show some bench scale at our lab in Palermo University. And here there is a pilot plant. As you can see in this pilot plant, we basically put some cover, movable cover, to collect the greenhouse gas that we are going to monitor, the direct emission, and to minimize, also using the mathematical modeling for this approach. A few words about the case studies. Both case studies are located in Sicily. I don't know, many of you know, Sicily is in the southeast of Italy. You can see is the largest island. And in this island, we have these 2 wastewater treatment plants, Marineo and Corleone, that basically distance from Palermo around 100 kilometers, and they are close to each other. Marineo, here there is a picture showing you the different treatment units going for pre-treatment, biological, and then the sludge, the watering, and also there is a unit for biofilters and UV, so for reuse of water. What we are going to do is that to overcome with AMAP some already main issue that are there. So there is no reuse, disinfection not working, no drying beds, storage ponds, pipeline damaged, and treated effluent discharge in the Lario River. So what we are going to do from this point is to build up a deviation line for pHa production. So we are going to treat part of this wastewater for produced pHa, but also to recover by using some filters filled by biochar and zeolite to recover both nitrogen and phosphorus. Here there is a picture showing you how it looks like the pHa will look like the pHa deviation line that we are designing and then put in allocate in the Marineo wastewater treatment plant. And here there is a scheme showing you the filters that we are going to locate also in this wastewater treatment plant in Marineo, which, as I said, are going to be filled by zeolite, biochar in order to absorb the nutrients and then to recover them from desorbing for the nitrogen and for enrichment by biochar for use in agriculture and so on. Concerning the Corleone wastewater treatment plant, the second case study, again, is a simple, a conventional created system with aerobic digestion. The inhabitant equivalent is around 12,000. I forgot to mention that for the previous one is 7,000, so it's a little bit more, but it's still, I will define a small wastewater treatment plant, which has the pre-treatment units, and then in this are located the activated sludge. One is empty, and then the secondary settler here in the bottom. One of them is not working, then the activated sludge. And here you can see an important unit that is ultrafiltration membrane for water reuse. So what are the current situation? So main issue is that there is no reuse in operation up now. One activated sludge reactor is empty, is not working, and secondary settling as well, and also an aerobic digester. What we are going to do is to upgrade in the sense that we want to optimize the system. So we will change the scheme of the plant in order to minimize the sludge production, and also to activate the water reuse for irrigation. Here there is one proposal that we already discussed with AMAP, that is the manager, the management of, in charge of the management of these two wastewater treatment plant, that basically consists in using one of an empty tank for oxic settling anaerobic process to minimize the sludge production. And this is one of the scheme, but we are going to decide the scheme also on the basis of the activity, the experimental activity that we will carry out, as I said, in the laboratory at Palermo University. We are going with the agriculture department, biotechnology department to study the interaction between soil, water, and plants in order to overcome some limits that are already present in the regulation. So we want to see if there would be some margins for having a wider uptake of this water smart solution. For the monitoring, we are going to carry out an extensive campaign, collecting also by using this wood, collecting the greenhouse gas, so the direct emission, but also indirect emission. So we are going to monitor the consumption of energy for the electricity and all facilities that are inside the wastewater treatment plant. And of course, we are going to carry out analysis for conventional parameters, COD, BOD, and so on, but also microbial analysis, metagenomic analysis for trying to optimize the operation of the two wastewater treatment plants. As I said at the beginning, we are carried out by using this database. We will model the system using an approach that goes from complex model to simplify in order to come up with a roadmap for wider uptake. That is one of the main deliverables of the project. So this will be an important part that will also guide impartially the experimental analysis that we are going to develop. Of course, we have some challenge for having wider uptake. Here, I just mentioned some of them. One important is that the revamping for the wastewater treatment plant equipments, and also some local regulation that we are going to face, because we want to engage as much as possible company and people and so on, and we also to break the social acceptance about the reuse of these components coming from the wastewater treatment. That is not an easy task. So this is one of probably a big challenge that we are going to face, and also, as I said, administrative acceptability of the need to update, modify the plans. But it seems that the project already is going to be having a success in terms of acceptance. So we are going to communicate as much as possible the activity in order to involve people and then to convert, to modify their attitude. So the way of seeing, I would say, some material that is recovered from wastewater that generally is seen as something that is not very nice, I would say. So thank you. That's it. That's all. Thank you very much for your listening. And I would like to thank, first of all, the principal investigator, Herman, of the project, and all of you for your listening, and looking forward to your question. Thank you.